Hello friend, welcome to the channel Pharmacy Dictionary. We are studying about the Pharmacokinetic Unit 1 of Pharmacology 1. But this video is the last for that topic, and that topic is Kinetic of Elimination, their basic introduction. After this topic, we are going to upload a separate executive model question paper for your B Pharma examination point of view. So please do attend upcoming next video. In today's lecture, what is the meaning of kinetic of elimination? In pharmacokinetic, there are four parameters, out of which the one is very important, absorption and excretion, because the one is representing first process and the last one is representing the last one. So if the absorption and excretion or elimination of the drug in a proper harmonized manner, then everything will be okay. But have you think ever that what will happen if the absorption is progressively increasing, whereas the excretion or elimination is not proportionally working on that? The excretion is going down, then what will be happen? So the amount of drug in our body, specifically in our blood and in our plasma, will be higher, and that may convert into a toxic or accumulative effect. So to avoid these circumstances, we need to equilibrize the administration as well as the excretion process that is maintained by our body kinetic phenomena. This is called study of kinetic of elimination of any drug. So as per the definition, we should understand the meaning of clearance. Clearance is not exactly elimination. Clearance is representing the removal of drug from the plasma, whereas the elimination represents removal of drug from the blood, but these two terms are not exactly same as it look like. So what is the meaning and definition of clearance? As per the theoretical value, as per the definition from K.D. Tripathi, the clearance definition says clearance of the drug is theoretical volume of plasma from which the drug is completely removed in a unit time. See, these words are very clisty and very important. Clearance of the drug is a theoretical value. It is not exactly practical value, which indicate that volume of plasma is not about the volume of drug. It's talking about the volume of plasma. So volume of plasma from which, that means the drug has bounded to the plasma. But now, what amount of plasma by which or from which the drug is completely removed in a unit or a specific time is called clearance. That is not exactly as indicate as a excretion. So you have to understand this definition very clearly. Now, what is the formula or equation of this clearance? Clearance is represented as a CL in capital. So the formula of clearance is rate of elimination. See, if this term could be a same, then why we are using the same term in the same formula? That is why these two terms are different. Elimination and clearance both are different. The formula of clearance is rate of elimination divided by C, where C is representing the plasma concentration. That means rate of elimination is also having two consequences. The main and important word is rate. Rate is always time specific, and if you are talking about the rate word, you are using the rate word. The process should be as per a specific time unit. It may be seconds, minute, hour, day, month, year, whatever it is, but that should be in a value of time. So the definition is clear here. Now we have to study about the order of kinetic or kinetic of elimination. So as per the concentration gradient phenomena, the kinetic of elimination can be classified into two types. The first one is first order kinetic and the other one is zero order kinetic. In some book, the sequence may be variable. Few book represent zero order kinetic first and the second one for first order kinetic. It doesn't change the manner, it doesn't change the frequency, but only sequence can be altered. So let me clear with the first order kinetic. What are the basic consequences? What are the basic equation? So I have converted a theory into a general equation which you have studied in your standard questions. So this is, that means first order kinetic is rate in this kinetic. First order kinetic equal to rate of elimination is totally directly proportional to the drug concentration. Means if you want to define this order, you can simply put a formula. Rate of elimination is directly proportional to the drug concentration. That means if you are increasing any of the value here, rate of elimination, that means if you are increasing the elimination or increasing of drug from our body, elimination is taking place, then simultaneously drug concentration can also be variable. So if you are increasing the concentration of drug in our body, then their elimination will be also increasing. So both are parallelly, like I have given you the example. If you are increasing, this will increase, they will work simultaneously. So this is very important definition. So now what is the basic point regarding this first order kinetics? See, clearance remain constant. The clearance, not elimination. Please do not be confused with these two terms. Clearance means from plasma. Clearance remain constant or a constant fraction of drug present in the body get eliminated in a unit time. constant amount of plasma, it is very important, or specifically if you are talking about the blood, then you can say a fraction of drug present in the body get eliminated. If you are talking about the clearance, then you should represent the word plasma. If you are talking about the elimination, you should represent the body. These two terms are correlated. So next point say applies to the majority of drug which do not saturate the elimination process like transporter, enzyme, blood flow, etc. The first kinetic of elimination or first order kinetic is specifically followed by majority of drug. So see, applies to the majority of drug. The main point is here, which do not saturate the elimination process. If the process of elimination becomes saturated, now more drug will not be eliminated, and those drugs which are not able to get eliminated from our body will stay in our body, so that may convert into accumulation effect. But here it is not saturable, so this is said don't saturable. It is very important word. This is the main difference between these two terms, first order and zero order. They do not saturate, so that is why there is no chances of being over accumulation. So the process of transporter or process of saturation involve the interaction of transporter which transport a drug from one part to the another one, as I have explained in the previous one. Same like enzyme and blood flow, the particular organ. So if these are not saturated, the saturation process will not be take place. So please do remember this don't word. Now coming to the zero order kinetic, as its name indicates, it is not dependent upon the concentration. So let me clear you the another term which is used for these two terms. First order kinetic depends upon the concentration of the drug, but zero order kinetic does not depend upon the concentration of drug. This is very important difference between these two terms. So what is saying the zero order kinetic? Rate of elimination remain constant irrespective of the drug concentration. It is not respective, it is irrespective. That means does not depend upon the concentration of the drug. So there is chances of accumulation here. So clearance, that is Cl represent for the clearance. Clearance decrease which increase in concentration. So clearance, if clearance will be decreased, there will be increase in the concentration. Or we can say in other word, or a constant amount of drug is eliminated from body. I have already explained you, if you are using this eliminated word, then you should use body. But if you are using clearance word, then you should use plasma. These two things are very important. Now let me give you the few examples related to this. So example of those drugs which follow zero order kinetic are alcohol. Along with alcohol, there are few more examples like heparin, phenytoin, aspirin. So these 3 to 4 drugs are following zero order kinetic. So what is the another point? Also called capacity limited elimination. That means the zero order kinetic is also called as a capacity related elimination. Now another most important point say that enzymes saturate, as I have explained you in case of first order kinetic, that does not saturate, but in case of zero order kinetic they get saturated. So once they get saturated, what is going to be happen? There will be a increase in the dose. If you increase in the dose will increase the plasma concentration of the drug, and they will actually convert it into a toxicity, because the elimination will not be facilitated because that process has been already saturated. So here I have explained increased plasma drug concentration, disappropriate elimination will not be disappropriate elimination will take place, and that will convert it into a toxicity. So this was basic terms, only definition we need to study about, nothing is there. So this was two terms, first order kinetic, clearance, and zero order kinetic. Clearance was basic to understanding these two terms, while two important terms where only first order and zero order kinetic. So friend, that's all for the day. Thank you very much for watching this video. The reference for today's topic is KD Tripathi 8th, and that is latest edition. For upcoming video, please be with us because we are going to upload a whole unit 1 model question paper as per your PCI syllabus. So at last, thank you very much for watching this video. Please do take care of yourself. Thank you. Namaskar.